Jai Hind. Today we discuss about the hydropower plant and some basics of the power system. So first we discuss basic structure of power system. What are the basic structures? So basically the power system have a three components. First one is generation, second is transmission, and third one is distribution. Distribution of electricity. Here we discuss in detail. So first we generate the electricity by using the hydropower plant, thermal plant, nuclear plant and some other plants. So first we generate the electricity, then we need to transfer it to the load center where it can be consumed. So it is going through the transmission. The system that used to transmit the electricity from generating station to the consumer end, that is transmission system. They are having high voltage power lines. It uses high voltage power lines. Basically they have a 132 kV, 220 kV, 400 kV and 765 kV generally used. The level of voltage goes with increasing with the distance. If we need to transfer the electricity for a higher distance, then we go for the extra high voltages like 400 and 765. So these dependent on the distance of the power transmission, how much distance we have to cover it. And the generation, if you are talking about the generation, so generation voltages are 10 kV to 20 kV. So generally we are generating electricity at 11 kV and we can take from 10 kV to 20 kV for the generation. Then here we are having the distribution end, where we are having three type of consumers: industrial consumers, commercial consumers and residential consumers. Here it is, the industrial they take 11 kV generally or 33 kV. Industrial consumers. Commercial consumers, they generally take 3 phase 400 volt 3 phase or 230 volt single phase. Residential consumers, they generally take 230 volt single phase for their house, but they may take 400 volt 3 phase for their agricultural demands. So these are the components of the power system dependent on the voltage. These voltages are fixed. Here we are talking about the generation, because we are going to discuss the hydropower plant. So at generating stations we are having hydro plant, or maybe thermal, nuclear. Okay, so three major plants are there to generate the electricity. And we can also say that we are having a solar plant, that is the renewable energy resources. In fact, renewable energy resources contain hydro plant also. Renewable means they are renewed itself. They don't need to, they are not going to end like coal plants coal are lasting, here nuclear. Now we are discussing the structure of electrical power system. What are the structure of this power system? So as we have discussed that we are having first generating stations where we generate the electricity. Then here it comes a power transformer. The work of power transformer, the working of power transformer, that is used to step up the voltage and up to transmission line voltages. Means if you are having 11 kV volt here, then here it is 220 kV. 220 kV. 220 kV or 400 kV. So it is used to step up the voltage that is generated at generating stations. Then we are having transmission lines, primary transmission lines and secondary transmission line. Then we are having transmission substations also there, where we can do step down the voltage at our demand. Here this is distribution stations. Here we drop the voltage up to 33 kV. Then again we can drop it 11 kV. So from 33 kV the distribution ends start. Okay. Then here it is residential consumers. Here it is commercial and industrial consumers. They take maybe 33 kV, 11 kV, and here it is only 400 or 230 single phase. So these are the structure of the electrical power system. Now we are going to discuss the source of electrical energy, and here it is the layout. We can see here that is a single line diagram. Single line diagram. Here it is generating stations, generating 11 kV volt. Electricity step up, it is step up to 220. Then here it is step down 220 to 33 kV. Again it is step down 33 to 6.6 kV. These are the symbols of the transformer. These are the symbols of the transformer, and these lines are called the feeder lines. Okay. Here again we can step down it from 33 to 6.6, and here from 6.6 to 400 or 230, depending our demand. What are the demands of the consumer? Means they are industrial consumers or residential consumers or commercial consumers. So depending on that we give the step down, how much we can take it. Here it is the source of electrical energy. What are the source? We know that we are having two sources of energy, that is renewable energy sources and the conventional sources, non-renewable energy. It is also called the conventional energy sources, and here it is renewable energy sources. Renewable means it comes with the wind plants, solar, hydro, tidal, geothermal. Geothermal plants are also there, and here it is non-renewable, thermal, nuclear, diesel plants are there. So these are the renewable energies. So we have to, now we are trending to use renewable energy sources, because we are knowing that at some time the thermal, nuclear and diesel plants are end. So that's why we are moving, we are promoting the renewable energy sources. We are going with the solar plants, wind plants. We are having wind plants at the coastal areas. These are generally planted at coastal areas. Coastal areas. And these hydro plants, they are planted at generally at hilly areas. Okay. So now we are going to discuss with the hydro plant. So basically, hydro plant, the generation of electricity by the hydropower. Hydropower means the power of water. The power of water means potential energy in is what are the potential energy stored in the water, we can convert it into the kinetic energy. So here it is, the generation of electricity by the hydropower, that is potential energy in stored water, is one of the cleanest methods of producing electrical power. One of the cleanest method to produce the electrical power. And as a data of 2012, the hydroelectric power plants contributed about 16% of total electricity generation of the world. Now it is going to be increased. It is almost 20% and 20 to 25% nowadays. And hydroelectricity, it is the most widely used form of renewable energy. It is widely used. It is a flexible source of electricity, and also the cost of electricity generation is relatively low. The cost of electricity, that depends upon the input of the plant, and here it is renewable energy sources. We are not going to give any charge on the water, that is free, water is free. So that's why the electricity generated through this plant have a lesser cost as comparison with the thermal plant or nuclear plant. Okay. So the layout of the, what are the layouts of the hydro electric plant we see. So basically there are the some components. Here it is dam. Basically dam is used to create a height of the water, because we are as much height, we know that the potential energy, that is mgh, that is your potential energy. So we are going to generally, what we are going to do, we are going to convert this potential energy into the kinetic energy. So as much height is there, that is potential energy is more, so mg is there, so that's why we are providing height. So dam is used to divert the water with a very specified path that increases the velocity of the water. Okay. So here it is dam, and behind this dam there is reservoir. The pani is stored, the water is stored here. Water is stored. Water is stored, that can be have with the help of river, canal. Okay. So this water is going through this turbine with the penstock. Penstock, it carries the water, and here it is the surge tank. Here it is the control gate. It is control gate. We are discussing after this. And here it is also the outflow water. This is outflow water. Okay. And here it is the turbine that is connected with the generator, the prime mover of the generator. The shaft of turbine is mounted with the shaft of the generator, and here it is generator, and we are producing electrical energy, and then we transmit, we use it. So here the components, basic surge tank is valve house, penstock, power stations, tail race, that is used to reserve the water after used. When we use the water, means we have done our work, then the remaining water is stored here, that is called the tail race. Here it is the pressure tunnel, that is used to control the pressure in the pipe of the penstock. Here, so we are discussing here one by one. So first, dam and reservoir. So dam is constructed on a large river. It is constructed on a large river in hilly areas to ensure sufficient water storage at height. The dam forms a large reservoir behind it. The height of water level called as water head. So we have, if we are going to increase the speed of the turbine, then we have to increase the height of the head in the reservoir, and that determines how much of potential energy is stored in it. We know that mgh, as h is increases, the total potential energy increasing. Here it is control gate. Control gate, the water from the reservoir is allowed to flow through the penstock to the turbine. So the amount of water which is to be released in the penstock can be controlled by control gate. So how much amount of water we are going to deliver to the turbine, that is controlled by the control gate. Okay. And this control gate is when control gate is fully open, it means maximum amount of water is released through the penstock. Okay. Means we can control the output of the generator through this control gate depending upon the demands. As we know that the load demands goes on changing on hour to hour. Okay. So that can be controlled by the control gate. Means if we have to produce more electricity, then we have to input the more water into the turbine, that increases the speed, and hence that increases the electricity demand. And here it is penstock. Penstock is huge steel pipe. It is a huge steel pipe which carries water from reservoir to the turbine. It is a steel pipe that carry the water from reservoir to the turbine. With the help of penstock, we can carry the water from the head to the turbine. Potential energy of the water is converted into kinetic energy as it flows down through the penstock due to gravity. Okay, we all know that here the water is flowing and here it is turbine. So water, the potential energy, what the potential energy of the water, here it is the potential energy, now it is converted into kinetic energy, half mv square. So this kinetic energy is used to produce the electricity, is used to drive the blades of the turbine. Basically this this kinetic energy of water is used to drive the blades of the turbine, and that blades move the shaft of the turbine, hence the rotor of the generator rotates. We will get the electricity at the terminals of the generator. Water turbine, the water from penstock is taken into the water through the turbine, and turbine is mechanically coupled to an electric generator. The kinetic energy of water drives the turbine, and consequently the generator gets driven. So there are two main types of turbine. First one is impulse turbine and second one is reaction turbine. Basically impulse turbine, they are used for high speed, they are used for high heads, they are used for large heads, and reaction turbines are used for low and medium heads. So impulse, that is used for high head, means used for large power, and reaction, that is used for low and medium power. Okay. Then here it is generator. A generator is mounted in the powerhouse and it is mechanically coupled to the turbine shaft. When the turbine blade are rotated, it drives the generator and electricity is generated. after the generation of electricity, we can step up the voltage of the electricity, and with the help of power transformer, we transmit it for consumption purpose. Here some more components are there. There is surge tanks are there. The surge tanks are usually provided in high or medium head. So surge tank not generally provided for low head plants. It provided only in high or medium head plants. Okay. So surge tanks are usually provided in high or medium head power plants when considerably long penstock is required. A surge tank is a small reservoir or tank which is open at the top. Basically, it is used to control the pressure in the pipe of the penstock, because we all know that the load demands are changing with the hour basis. So suppose if we are having to reduce the output and we are supplying a continuous supply is there, then we close the valve at the turbine, and at the same instant the water hammers in the penstock. It can break the penstock. The advantage of this surge tank is just to carry at this time to carry the extra water in the pipe, and it having more advantage that if you are having a sudden load demand, sudden extra load demand, so we can take water from the surge tank to fulfill that demand. Okay. So it is fitted between the reservoir and powerhouse. Water level in surge tank rises or falls to reduce the pressure swing in the penstock. When there is sudden reduction in the load on the turbine, the governor closes the gates of the turbine to reduce the water flow. Okay. And this causes pressure to increase abnormally in penstock, and this is to be prevented by using a surge tank in which the water level rises to reduce the pressure. On the other hand, the surge tank provides excess water needed when gates are suddenly open to meet the increased load demand. So we can take the advantage of this surge tank. If you are having the extra load demand, we can take the supply from the surge tank. If you are having low load demand, then we can reserve the water to the surge tank. We can reserve the water to the surge tank, means there is no wastage of the electricity, and our power system is stable due to this. We know that if load demand and supply do not match, then the power instability comes out and our total breakdown will take place. Okay. Some more points also there. It is a small reservoir that we have discussed, which is open at the top. It is fitted between the reservoir and the powerhouse. Here we can see that here it is the reservoir, and here it is the turbine. In between this is your surge tank. Okay. This is your surge tank that is connected in upward direction. If the load demand increases, we can take supply from, in case of load increases, we can take water from the surge tank, and in case of load demand decreases, so we can give the power, means means water is uplifted to the surge tank. In this way we balance the system. We having balanced the system as okay, and this water level in the surge tank rises or falls to reduce the pressure swings in the penstock. When there is sudden reduction in the load on the turbine, the governor closes the gates of the turbine to reduce the water flow. This causes pressure to increase abnormally in the penstock, and this is prevented by using a surge tank in which the water level rises to reduce the pressure. On the other hand, surge tank provides excess water needed when gates are suddenly open to meet the increased load demand that we have discussed. Types of hydropower plants. First we discuss about the conventional plants. What are the conventional plants? So conventional plants use potential energy from dammed water. This conventional plants that uses the potential energy from dammed water means that the plant having dam, the hydro plant having dam, okay, and energy extracted depended on the volume and head of the water. How much head of the uh, water is there, or what is the volume of the water is there. So generally these are the big plants. These are the big plants means they are used for high power generation. High power generation. High power generation, and their cost is also high. Their cost means their uh, installation cost high. Okay, their installation costs are high, and here it is. The energy extracted depends upon the volume and head of the water. The difference between the height of water level in the reservoir and the water outflow level is called the water head. What is the level of, here it is the head, and here it is the, this one distance is called your head. This is your dam, you can take it, it is ground level. So this is your H. Next, that is comes with the pumped storage plant. As with the name it is clear, it is pumped storage plant. In pumped storage plant, a second reservoir is constructed near the water outflow. A second reservoir is there with water outflow, means after water is bypassing through the turbine, water is stored in some what near to the outflow. Then we are having in this plant, we are having an extra reservoir to store the water. What it means? It means that the when we are having a extra load demand, as we know that the load demands are vary with time. So in case of extra load demand, we can take the advantage. How? In case of low load demand, we can supply the water from downward to upward in case of low load demand. And when load demand increases beyond our capacity, then we can take the advantage this uplifted water. Okay. So is uplifting, it means in pumped storage plant, a second reservoir is constructed near the water outflow from the turbine. When the demand of electricity is low, the first one, the water from lower reservoir is pumped into the upper main reservoir. And this is to why we are doing this? This is to ensure sufficient of water available in the main reservoir to fulfill the peak load demand. Means when we are not having a we are not having the peak load demands, so we can uplift the water to the main reservoir, and we use it in case of peak load demand. So in this way we balance the supply and the demand. So that is the extra advantage of pumped storage plant. So we can take the advantage of this. Generally nowadays every conventional plants having a one extra storage to meet the peak load demands. Generally we are having. Now the third one is runoff river plant. In this type of facility, there is no dam, that is runoff river. No dam is constructed, hence reservoir is absent. There is no reservoir. Okay. A portion of river is diverted. In this case, the portion of river is diverted through a penstock or canal to the turbine. Thus, only the water flowing from the river is available for the generation. Means there is no storage of water. Okay. So we cannot supply the peak load demands. In this case, there is no peak load demand, no peak load supply. Okay, there is no storage, there is no peak load supply, and due to the absence of reservoir, any oversupply of water is passed unused. So this is another type of hydro plant, that is runoff. Runoff generally it is in um, rainy season when our rivers goes flooding, then we can use these type of plants. Here it is, the last topic is hydroelectric plants. First we discuss advantage. What are the advantages there? So no fuel is required as potential energy is stored, water is used for the electricity generation. There is no fuel because water is free, and neat and clean source of energy, because we all know that in case of nuclear and thermal plant, we are having much pollution over there. So in this case there is no pollution. Okay, there is no harmful pollution. That is neat and clean source of energy. Very small running charges, as water is available free of cost. Comparatively less maintenance is required and has longer life. And it serves other purpose too, such as irrigation. We can use the water in irrigation, okay, by passing through some small canal. Okay, we give supply to the uh, fields of the farmers. We can um, use it in irrigation. So in this way, this hydro plant is very advantageous because of this renewable energy sources. Every country is going to increase the use of this plant. Okay. Now, what are the disadvantages? Disadvantage that is very high capital cost due to construction of dam. So due to the construction of dam, the cost of this plant increasing. Okay, and high cost of transmission. Why it is? Because it is situated, it is located in hilly areas which are quite away from the consumers. So two things that one is capital cost and one is the high cost of transmission. That comes a disadvantage of this hydro plant. Okay, seen that the hydro plant that is used almost 20 to 25% nowadays, and it goes on increasing because we are lefting with the uh, conventional plants like thermal and um, nuclear plants. Okay, so today's topic is over. Okay, now Jai Hind. Jai Hind.